Ford is hitting the accelerator on electric vehicle production.
Built in the U.S. by U.S. workers and not be imported.
Ford just unveiled something that could reshape the automotive landscape as we know it.
We've just seen a big change in customers. It's going to be as exciting as an electric vehicle. It's just a little different than what we thought it was going to be a couple years ago.
Their latest engine technology isn't just an incremental improvement. It's a fundamental rethinking of how internal combustion engines can coexist with our electric future.
Delivering those ideas in a way that millions can access them. But I know Ford is the company that can and will pull this off.
While most manufacturers are racing toward full electrification, Ford has taken a different approach, one that acknowledges the reality that millions of drivers aren't quite ready to abandon traditional engines entirely. The power-dense revolution. At the heart of Ford's innovation lies what they're calling power density optimization. Traditional engines have always faced a trade-off between size, weight, and performance. You want more power? You typically need a bigger engine. Ford's engineers have essentially broken that rule. Their new 3-cylinder turbocharged units deliver power outputs previously reserved for much larger 6-cylinder engines, all while weighing significantly less and occupying a fraction of the space. The secret isn't just one breakthrough, but rather a combination of advanced materials and manufacturing techniques. Ford has incorporated aluminum alloy blocks with high-pressure die casting, a process that allows for thinner walls without sacrificing structural integrity. The result is an engine that's roughly 15% lighter than comparable units from just 5 years ago. And weight matters more than most people realize. Every pound shed from an engine translates directly into better fuel economy and improved handling dynamics. But the real magic happens inside the combustion chamber. Ford has developed a new coating technology for cylinder walls that reduces friction to levels previously thought impossible for mass production engines. This nano-ceramic coating, applied through a plasma spray process, creates a surface so smooth that it actually allows the pistons to move with less resistance than traditional cylinder linings. The friction reduction might sound minor, around 8%, but in real-world driving conditions, this translates to meaningful fuel savings and reduced wear over the engine's lifetime. Breathing new life into combustion. Turbocharging isn't new, but Ford's implementation certainly is. Their latest generation of turbochargers uses electrically assisted compressors that eliminate virtually all turbo lag. Anyone who's driven a turbocharged car knows that brief hesitation when you press the accelerator. That moment where you're waiting for the turbo to spool up. Ford's electric assist spins the compressor immediately, providing boost pressure from idle. It's a hybrid approach without actually being a hybrid vehicle, using small amounts of electrical energy to dramatically improve the driving experience. The air flowing into these engines passes through a redesigned intake manifold system that Ford claims improves volumetric efficiency by nearly 12%. Essentially, the engine is breathing better, pulling in more air with each intake stroke. More air means more complete combustion, which means more power and cleaner emissions. The manifold design incorporates variable geometry that adjusts based on engine speed and load, optimizing airflow across the entire rev range rather than just at peak power. Ford has also integrated their latest direct injection technology, capable of multiple injection events per combustion cycle. During a single piston stroke, fuel might be injected 3 or even 4 separate times, each spray time precisely to optimize combustion efficiency. This level of control allows the engine to run leaner when cruising, using less fuel, while still delivering maximum power when you need it. The injectors themselves operate at pressures exceeding 350 bar, atomizing fuel into a mist so fine that combustion becomes remarkably complete and clean. The electrification connection. Here's where things get interesting. Ford isn't developing these engines in isolation from their electric vehicle program. Instead, they're creating what they call electrified combustion systems. These engines are designed from the ground up to work seamlessly with mild hybrid systems, incorporating 48-volt electrical architectures that can recover energy during braking and provide electric boost when accelerating. The mild hybrid system does something clever with what would otherwise be wasted energy. Traditional engines lose enormous amounts of heat through the exhaust and cooling systems. Ford's new setup includes a thermoelectric generator mounted in the exhaust stream that converts some of that waste heat directly into electricity. The output isn't massive, maybe enough to power the vehicle's electrical accessories, but that's energy that would have simply disappeared into the atmosphere. Every watt generated this way is a watt the alternator doesn't need to produce, which means less parasitic drag on the engine. The 48-volt system also powers an integrated starter generator that makes stop-start functionality so smooth you barely notice it. The engine shuts off at red lights and restarts instantly when you lift off the brake. Unlike earlier stop-start systems that felt clunky and intrusive, Ford's implementation is seamless. The electric motor can even propel the vehicle at very low speeds, like when creeping through a parking lot, without the combustion engine running at all. Real-world performance. So what does all this technology actually mean when you're driving? Ford has installed these engines in several of their popular models, and the results are genuinely impressive. The 1.5-liter three-cylinder unit produces 180 horsepower and 210 pound-feet of torque, numbers that would have required a 2.5-liter or larger engine just a decade ago. Yet this compact power plant returns fuel economy figures in the mid-40s for highway driving in vehicles like the Escape crossover. The power delivery feels linear and responsive, without the peaky characteristics that plagued earlier small-displacement turbocharged engines. You press the accelerator, and the vehicle simply goes. No drama, no waiting. Ford has calibrated the throttle mapping and transmission programming to work in harmony with the engine's power characteristics. In real-world testing, vehicles equipped with these engines accelerate from 0 to 60 mph in under 8 seconds, perfectly adequate for daily driving and highway merging. Noise and vibration have traditionally been challenges for three-cylinder engines. That inherent imbalance creates a characteristic thrum that some find unrefined. Ford has addressed this through a combination of counterbalancing shafts and active engine mounts that use the 48-volt electrical system to generate opposing vibrations, effectively canceling out the engine's natural frequency. Inside the cabin, these engines are remarkably quiet, often quieter than larger four-cylinder units from competitors. The environmental angle. While electric vehicles capture headlines, the reality is that internal combustion engines will remain dominant in many markets for at least another decade. In this context, improving the efficiency of conventional engines has a massive environmental impact. If Ford can improve fuel economy by even 15% across their entire fleet, the cumulative reduction in emissions is substantial, potentially more impactful in the short term than selling a smaller number of EVs. These new engines meet stringent emission standards without the complex and expensive after-treatment systems required by older designs. The improved combustion efficiency means fewer harmful emissions are produced in the first place. Particulate filters are smaller and lighter, catalytic converters require less precious metals, and the engines can run cleaner overall. Ford has achieved Euro 6D and Electrified certification, among the strictest emission standards currently in force. The manufacturing process itself has environmental benefits. The power density improvements mean Ford can produce more engines in the same factory footprint. The reduced material usage per engine adds up quickly when you're building hundreds of thousands of units per year. Aluminum recycling is also more energy efficient than steel, and Ford has increased the recycled content in their engine blocks to over 50% without compromising quality or durability. Engineering challenges overcome. Developing these engines wasn't straightforward. Increasing specific output, the amount of power produced per liter of displacement, creates tremendous thermal and mechanical stresses. Ford's engineers had to completely rethink cooling systems to handle the increased heat generation. The new designs incorporate 3D printed cylinder head cores that allow for cooling passages impossible to manufacture through traditional methods. Water flows through intricate channels that target the hottest areas with precision, maintaining optimal operating temperatures even under sustained high-load conditions. Durability testing pushed these engines to extremes far beyond normal driving conditions. Ford runs prototype engines continuously at maximum output for hundreds of hours, simulating decades of real-world use compressed into months of testing. They operate engines in climate chambers ranging from Arctic cold to desert heat, ensuring reliable starting and operation anywhere customers might drive. The goal is 200,000 miles of trouble-free operation, and early results suggest these engines will meet or exceed that target. One unexpected challenge involved oil selection. The reduced friction coatings and tight tolerances required development of specialized lubricants that maintain viscosity across wider temperature ranges while providing the film strength needed to protect components under extreme pressure. Ford worked with oil manufacturers to formulate blends specifically optimized for these engines. Using the wrong oil could actually reduce efficiency and potentially cause long-term damage, so Ford has been very specific about their lubrication requirements. Market positioning. Ford isn't marketing these engines as revolutionary, which is actually quite smart. Instead, they're positioning them as practical, efficient solutions for customers who want modern performance without the range anxiety or charging infrastructure concerns of pure electric vehicles. The engines appear across Ford's lineup, from compact cars to mid-size SUVs, providing a consistent experience and allowing economies of scale in production. Pricing is competitive, another crucial factor. These advanced engines don't carry significant premiums over conventional power plants, making them accessible to mainstream buyers. Ford has absorbed much of the development costs through manufacturing efficiencies and shared components across multiple models. For consumers, this means getting cutting-edge technology without breaking the bank, a compelling value proposition in today's market. The engines also serve as a bridge technology. Customers who might be curious about electrification but not ready for a full EV can experience some of the benefits, like silent operation in electric mode and instant torque from the hybrid assist, while retaining the familiarity and convenience of a traditional vehicle. It's a smart strategy for gradually shifting consumer preferences rather than forcing an abrupt transition. What competitors are doing. Ford isn't alone in this pursuit. General Motors has invested heavily in their own advanced small displacement engines, though their approach differs slightly, focusing more on cylinder deactivation technology that shuts down cylinders when they're not needed. Stellantis has developed what they call multi-air technology that precisely controls valve timing without traditional camshafts. Toyota continues refining their naturally aspirated Atkinson cycle engines that power their hybrid lineup. European manufacturers like Volkswagen and BMW have long championed small turbocharged engines, but they're facing challenges meeting increasingly strict emission standards. Ford's clean sheet design approach, starting fresh rather than evolving existing architectures, has given them some advantages in meeting these regulations without resorting to overly complex exhaust treatment systems. Japanese manufacturers like Honda and Mazda are pursuing interesting alternatives. Mazda's Skyactiv X engine actually uses compression ignition, like a diesel, but runs on gasoline. Honda has developed a unique variable cylinder management system. The competition is fierce, and each manufacturer believes their approach offers distinct advantages. For consumers, this technological diversity means more choices and rapid innovation across the industry. Looking forward. Ford's engine development roadmap extends well into the 2030s, even as they simultaneously invest billions in electric vehicle technology. The company recognizes that different markets and different customers have varying needs. While urban drivers in developed countries might embrace EVs, rural customers and those in regions with limited charging infrastructure still need efficient, reliable internal combustion options. Future iterations of these engines will likely incorporate even more electrification. Ford is researching 48-volt systems capable of providing meaningful electric-only range, blurring the line between mild hybrids and plug-in hybrids. They're also exploring sustainable fuels, ensuring these engines can run on synthetic gasoline produced from renewable sources, potentially achieving carbon neutrality without abandoning the combustion engine entirely. The manufacturing techniques developed for these engines are already influencing Ford's electric motor production. The precision casting methods, advanced materials, and quality control processes transfer across product lines. In many ways, the discipline required to extract maximum efficiency from combustion engines makes engineers better prepared to optimize electric powertrains. Ford has demonstrated that the internal combustion engine isn't a relic destined for museums, but rather a technology still capable of meaningful evolution. These new engines deliver power, efficiency, and environmental performance that would have seemed impossible just a few years ago, proving that innovation doesn't always mean abandoning what works, but sometimes means perfecting it.